Hi everyone, today we are introducing you to dilations, starting you off by talking about points, dilating points, and the concept of scale factor. As a reminder, you do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Be careful, make sure you don't fast forward too much that you end up missing out on something important. So let's start off with a review of dilation. Dilation is when you minimize or maximize the size of a figure based on the scale factor. So knowing that already, it's probably not going to be a rigid transformation, right? Because you're changing the size, you're not cloning it, you're not going to create congruent images. Scale factor is bolded because that's an important concept you're going to be using when you are performing dilations. The scale factor is going to tell you how much you are minimizing or maximizing. So it's like a scale. For a point, if you're just dilating a point, which we'll talk about today, you're just changing the location based on the scale factor because a point can't change size. It's just a point, a location. And a dilation, since it minimizes or maximizes, it's going to change not only the size, but it's going to change the location because that image is going to take up less space or more space, so the location is going to change. All right, so this is an example of an image, an object being dilated to a larger image. So notice how the location is going to change. It's going to get further away from your dilation point, and it's going to take up a lot of space, or less space. Some tips: if you can, use a ruler to be precise, especially if you're doing it by paper and pencil. On a computer, it's going to be a little different, but if you can, use a ruler. My tip is to multiply each coordinate pair by the scale factor that is more precise. We'll go over what that means later. The scale factor tells you what will happen, so be very careful and focus on that scale factor. If your scale factor is a number less than 1, so that's going to be a fraction that's less than 1, your image is going to be a smaller one compared to your object. So if a scale factor of a half means that the image will become half of the original size. A scale factor equaling exactly to 1 means it's going to stay exactly the same, because like anything times 1 gives you the same number. So it's just like multiplication. So multiplying is the key here. Scale factor larger than 1 means that your object's image is going to get bigger. So for example, if you have a scale factor of 2, it means that the image will become twice the original size. And it'll be as well twice as far away from your center. So there's two different things going on there. Be sure to jot this down before we move on to some examples. Okay, we are going to start with dilating points. So we are first going to read the directions. It says to plot the image of point B under a dilation about the origin 0, 0, this is the origin here, with a scale factor of 4. Okay, so there's a lot going on here. First, we have a scale factor of 4, so it means it's going to get further away from our origin. Our point is 1, 1. So like I said before, we're going to multiply. It's a scale factor of 4, so we're going to multiply both of those by 4. So you're going to end up with 4, 4. And it is going to be supposedly 4 times the distance away from the origin. So if we plot 4, 4 now, it'll end up right there. It should be 4 times the distance away from it. So again, we just took that order pair. This is 1 and 1, and we multiplied it by 4 for both of them. Okay? That's all dilating points is. It's multiplication. Your scale factor tells you how far away it is, or close it is, for dilating points. Okay, so now with scale factor. They're going to be introducing to you figures as opposed to just points. So in this problem, they said that the pentagon A prime, B prime, C prime, D prime, E prime is the image of the pentagon A, B, C, D, E under a dilation. So this is the old one. This is the image. Very important. What is the scale factor of the dilation? So how did it get from here to there? What was the scale factor? Okay. Well, we know that the scale factor is going to tell us how it became bigger or smaller. This became smaller, so it's going to be a number less than 1. Okay? And one way that we can figure that out is we can just count one of these straight lines. 1, 2, 3, 4, 5, 6. AB used to equal 6. Now AB equals 2. Okay? So how much smaller did it get? It went from 6 to 2. So it divided. 6 had to divide by 3 to get to 2. So that's our scale factor right there. It had to divide by 3. So this new image is 1/3 the size of the old one. Okay? We have it changed to 1/3 because it's a number smaller than 1, and also the division bar tells us divide. So again, we counted the length of AB. It was 6. The length of A prime, B prime, the new one is 3. So that means it got smaller by 3 times. So it's 1/3. We could have also done that for BC. That's 3. And here is 1. So also 3 divided by 3 is 1. So the scale factor either way is 1/3. Notice I'm not using these slanted ones because I can't really count with those. Okay, so either way, the scale factor is 1/3. Okay. So here in a problem like this is our last example. They're going to give you the scale factor, and now they want you to work backwards and figure out what the length of a side is going to be. So go ahead and pause this video and try it on your own first. Okay, quadrilateral A prime, B prime, C prime, D prime is the image of quadrilateral A, B, C, D. So this one is the old one. Let me actually write it on the side over here. And then they're going to create a new one with a scale factor of 4. So this is a number that's greater than 1. So that means it's going to become bigger than the original, which is good because I can't imagine this becoming any smaller. Okay, so for this case, I wouldn't even sketch it, although it would look much bigger, right? That's just a sketch. If they want to figure out the length of segment C prime, D prime, it's going to be this length right here. Okay, so what I'm going to do is I'm going to count the original. That's 3. It is getting bigger by a scale factor of 4. So 3 times 4 means that it's going to become 12. So I don't even know if the sketch is correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, nope. 10, 11, 12. So it got even bigger than what I sketched out. Okay? So this is what I mean by multiplying is more precise. So we took the old length of CD, we multiplied by the scale factor of 4, 3 times 4, so we'll get 12 for our new one. Okay? Let me know if you have any questions as you work on these problems, but remember, scale factor is telling you your directions, so multiply away. And I'll see you in class.